Deep, how are you?
Doing well, thanks.
Great.
Hope you are too.
Yeah, man. So we're
Wonderful Thursday.
Yes. So what's going on?
So we're here today with another special guest. Surprise, surprise. I'd like you to introduce yourself with a correct pronunciation.
Mert.
Do you guys get that?
Mert.
How do you spell that?
M-E-R-T.
And then how do you pronounce your last name?
Coskun.
I'm not even good at it, damn.
So where are you from? What's the name?
Turkey.
Turkey.
Yeah.
Right on.
So Mert, as we mostly call him, and that's mostly to differentiate between Matt and Mert, because if you say Mert, it gets a little bit confusing. You've got a couple of Matts on the team. So Mert has been on the team for quite a while now. He actually started as a PM, right? Then moved over to be a developer and has worked on a lot of the hard problems that we solve. And sort of what we're sitting down to talk about today is continuing the set of conversations that you guys might have seen with Preeta and with Sumuk, and talking specifically more about the state manager with Mert. So before we get started, I'd love to hear a little bit more about your background, sort of how you came to the team, what you worked on over the time, and sort of what you've enjoyed.
Sure. I was a college hire. I came in as a PM. So within a year or so, the Replicator stack was just being created. And at the time, I got into the Replicator stack. Maybe like a year into it or so, we needed testers, so I became a tester for it unofficially, and then I became a dev for it maybe a year after that or so.
That's a cool transition. But this whole time you basically focused on that one thing, really. And then a lot of pieces
so
that...
once Replicator stack started, that I started basically focusing on it more and more. Yeah.
Awesome. Okay, so over the last few, I mean, we can start using the whiteboard and then talking a little bit more, but over the last few videos, we've explored a little bit about how we make reliable collections available for people to use. So Preeta walked us through the T-store, and then she sort of referenced a portion, like the state manager, and said that you'd go into further detail with it. Sumuk talked a little bit more about the replicator, and then below that how like we replicate the same data in all the replicas across multiple machines and write that to disk through the log, so that you can actually have the same data being stored across a minimum quorum set of replicas at all times for a transaction to be successfully committed. So this is the final piece of the puzzle for us to sort of the level at which we've had with these videos. So if you could talk to us a little bit more about how the state manager works in interacting with those different pieces, and start with maybe like a top level view so we get context for the people that might be watching this for the first time.
Okay.
And take it from there.
All right. So I guess we can just place it where it's in the stack first. So I would say that you would have reliability. So what's called the RAP talking to us. That's our gateway to the system. So reliability talks to us through the replicator interface. So that's what I suspect Sumuk would have described. So within the replicator, from the reliability perspective, within the replicator we have the V1 replicator, which does the quorum management. So durability across replicas is what it does. So we call V1 replicator or quorum manager. And then we have the log, which is the local durability, right? And we have the logging replicator that brings these guys together. There are a couple of other managers across this one, like so for solving smaller or specific problems like backup manager, version manager, serialization manager, much smaller parts. Then on top of it all, we have state providers, right? So we have T-store, RCQ, reliable concurrent queue, and those kind of state providers, things that implement iState provider 2 interfaces. So state manager is right here. So it basically acts like a state provider to the logging replicator and does the multiplexing, demultiplexing, so that we can talk to the other state providers, right? So if you let's look at why we needed it, right?
Sure.
So if you look at V1 replicator, it has a very similar interface that it talks to its state provider called iState provider. That's where the name comes from. And so can you think of any problems that you might have if you just have that kind of model, like V1 replicator to iState provider?
So in this particular system, you're saying that you're directly communicating.
In that system, what it looked like, you have the similar, I think it's called the iFabric replicator interface. And then we had the V1 replicator and nothing else, basically, right? So that one had to talk to the state
Several
provider
different
directly.
sets of, yeah. So I mean,
So it would have to talk to an I state provider, and I think then you had I fabric state replicator, I think.
so obviously this doesn't really scale. You have multiple sets of like stateful services, or up here, if this starts to expand, then there would be issues in race conditions, locks. You might not have efficiency in read-write. That would be the first thing that comes to mind.
Yeah, I think that you kind of touched on the point, right? So what happened when people built things like this? What would you say that you were very excited about this? You built your dictionary, right? In this case, it would be a volatile dictionary. So you would basically build a dictionary I-state provider.
Just to pause you for a second, so you used an interesting word there that maybe not everybody's familiar with. You said volatile dictionary.
Yeah.
What does that mean?
So that means that in our terminology, that would be in-memory only state provider
Yeah.
would be called volatile.
Cool.
So you build a dictionary I-state provider, everything works fine, and then I see that your dictionary works fantastically. I decide to build my queue, and I build my app using that queue. Everything is working great. Then when Charles comes in and says that, hey, you guys built these awesome state providers, and I have this service that requires an input queue, an output queue, and a dictionary in the middle,
Yeah.
right? So things that are coming in, they get buffered for a while, then they get processed, and then they go to an output queue. The problem is, since it only supported I-state provider and single I-state provider, he could not reuse the code that we wrote, right?
Hmm.
He would have to build a new
Multiple
state provider
providers,
that
yep.
would be called, 2 dictionaries and 1 queue state provider, right?
So every single case that you want to have, you need to have a custom state provider.
Yeah. So the thing that, so it did not have composability, right? So people could not write their own state providers, and we just, plug them in to make things work. And that's where State Manager comes into play. What it does is that it enables you to dynamically add and remove state providers. And so it acts like a state provider to the logging replicator. So from logging replicator's perspective, the life is very much similar to V1 replicator. There's only a single state provider. But it does this multiplexing, demultiplexing, so that these state providers can be added and removed.
So right now we have a few different kinds of data structures, if I can call them that people can use. So they can use a dictionary, they can use a queue, a concurrent queue. Say hypothetically, if we were to add more, how does the composability of how, like the way the state manager has been written today, how does it handle, like if it had to do that for one new kind of like data structure that we're introducing? Is it written in a fully flexible way that no matter like what people throw at it, it's going to work? Or does it require you or somebody else on your team to sort of go in and say, hey, we need to handle a new kind of data structure and build a custom state provider for that set or whatever sets might be related to that?
Yeah, so assuming, this iState provider 2 APIs is about like 27 APIs. So assuming that you kind of adhere to their behavior, adhere to their rules, you can build any kind of reliable state provider too,
Yeah.
and the state manager wouldn't have to change at all. Things that it might have to change for would be things like you need a hook because you have a very special case that you are
Sure.
doing a very special kind of isolation level, or you want to do a special kind of two-phase locking. Just maybe you want some things a little bit weaker. In those cases, that it is possible that interface might have to be extended.
So these 27 APIs that you just described, what are they? Like, can you just walk us through, not each of the 27, but what are they like? What are they grouped by?
So the main ones, first of all, is the life cycle, which is very similar to, there's another interface here called iStateful Service Replica. And it's very similar to the couple of the APIs it has, which is open, close, change role, so that we can open a state provider, we can change its role to become a primary, inform it when it's primary, when it's secondary. So some state providers might choose to maybe cache more if they're primary and less when they're secondary, or they might choose to not take locks if they're secondary. So the other one is that we would inform the state provider if we have detected a data loss, so that we can say, hey, state provider, there has been a data loss. You might want to take something to do with that. Then there's state. Then there's close, which is to say, hey, now you're going away, or change role to non-delete your state. Then there's kind of APIs that prescribe those a little bit better. Kind of say, recovered your checkpoint now, or delete your checkpoint, remove your state now. Then we have APIs that are more about the checkpointing. right? So we say I have 3 APIs. Checkpoints are divided into 3 APIs. I don't know if Sumuk went through them. So we would have, prepare checkpoint, perform checkpoint, complete checkpoint. And so we would call those on the state provider where, prepare checkpoint, we would just expect them to snap their state in memory, most likely, and get out of it really, really fast, or just return. And when we call perform, we expect them to, whatever they snapped, whatever the changes since the last checkpoint, we would expect them to write to the disk. And on the complete, we would expect them to kind of basically do a rename. So that your current file, your next file becomes your current file, and the other file gets deleted.
So in theory, that means somebody could also, if they implement, and they don't have a bunch of special use cases, they could implement their own effectively reliable collection or their own data structure, as long as they've implemented these APIs, correct?
Yeah, logically they could. So we have not publicly made these available yet. So once we do, we might want to kind of rethink some of these APIs, kind of make it so that it is less likely that there might be issues, kind of make it a little bit more easier to use.
Okay.
So I also want to take a slight tangent. You said that there's some complex scenarios in which it would be a lot harder to just implement these APIs as are, right? You sort of said that unless you want specialized hooks or like things like that.
I'm just saying that today maybe we haven't gone through the public API review, let's say.
Cool. And we plan to do that?
I think so.
Sure. If people are interested, Al, are you interested in this? You know who Al is. He's one of our biggest users. At least he likes to talk to us. Right on, Al.
Shout out.
Shout out to A. All right.
So talk to us a little bit more about the implementation. Go a little bit more into the weeds.
All right, so implementation, so I guess Preetha explained the T-store. It is a quite simplified version, you could say, of a state provider to T-store. So it has kind of smaller requirements, I could say, and that the number of objects you would have to handle is much less. So you would want to have, we call it the large store, right? So a store might have millions of keys and values. The number of collections we expect you to have is significantly less, so it was designed in a way that today it only does, for example, full checkpoint every time. It just does not expect too many state providers to be there. So locking would be very similar logically. So for example, what we, let's say, go through an lifetime of a state provider, right? At the beginning of time, state provider would not exist, right? So then you would decide to add it. So of course, so we do two-phase locking. Today there's rigorous two-phase locking. So what would happen is that we would acquire all the write locks. Right, we always acquire exclusive locks on the writes. So that then we would move it into kind of transiently insert or transiently edit state. Right. So at this point of time, there's kind of one difference between T-store and state manager. We do not allow the same transaction to see this change, but T-store would. So that's called the read your write feature. So we don't have that read your write. So at this point of time, it's locked, not only, and no one can see it, including the transaction who did the change.
Interesting.
What's the reasoning behind it?
Yeah, why is that?
It's just a lack of a feature today.
Okay.
Oh, okay.
There's no.
It's not like an efficiency thing.
No.
Okay.
So then, the next thing would be that at one point it would either commit or abort, right? If it aborts, it goes back to none. If it completes correctly or commits, it would go into kind of inserted state. At this point of time, any transaction who comes in is able to read it. So if you do, we have 2 APIs, I think, for doing the read right now. Publicly, one is the try get, which would do a read committed read for an isolation perspective. And then we would have, if you do get or add, it would, if it was an add, obviously it would take the exclusive lock, but if it was a read, it would be repeatable read, which means that we won't be able to delete it from other transactions, or other transactions won't be able to delete it until you let go. At one point, user might decide I don't need this dictionary anymore, which point is that kind of symmetrically would go to transient delete. right? So it's basically delete in flight. Once we if that one doesn't complete, of course, we go back to inserted state. So if you abort your transaction for one reason or the other, we go back to aborted state. But otherwise, we do something a little bit different. We do, soft deleted state, or it's also used for false progressing, which means that we temporarily still keep the dictionary until it is safe to remove it. And we can kind of discuss that.
Yeah,
if
we
that's
should.
interesting.
Yes, we should.
So if you see the add case is quite simple, and it should be very similar to what tstore does. What is the difference here? That why can't we just delete that dictionary immediately? The reason is that we don't know if we might still need that dictionary. So we might need that dictionary during a recovery because the log might still have an apply for that dictionary that it might want to redo as part of its recovery. And if we were to delete it, which means that deleting the state of the dictionary would not be able to apply that operation because it would have been deleted. Or if it's actually being copied at that moment, right? So we are building a new replica at that point of time, which is kind of reading the log from an older point, which means an older checkpoint and an older log. Then it is possible that while that dictionary is being moved to another place so that it can be the rest of the logs can be sent. We don't want to delete it at that point of time. We want to let go. We want to only clean
Sure.
it once we know. It will not be tried. It will not be. We do it once we know it cannot be false progressed. This delete operation cannot be false progressed. It cannot be required for copy, or it cannot be required during recovery. Is when we do it.
So what's checking when it is free to be deleted?
It's called a safe LSN check. That's the name for that.
What does that stand
So what this
LSN?
Safe LSN, logical sequence number. So every time you do an operation, it gets a logical sequence number.
Sort of talked about.
64-bit
Yeah.
integer.
Exactly. So it would be monotonically increasing. From the V1 perspective, it's monotonically increasing by 1. The second you go into the state manager level, there are gaps because the logging replicator has its own records. So it's just monotonically increasing at that point of time. So what we do is that we, at the end of a checkpoint, which is the complete stage, we ask, hey, what is currently safe? So if safe LSN is higher than someone's delete LSN,
Right.
we know that we are kind of
Able to
safe
delete.
to delete it.
Cool. Nice.
Yeah.
Smart.
Yeah. Were you gonna walk us through the removal? Or you're just saying that this is the add case? What are some of the other?
So this would be the add path,
Yeah.
adding, committing,
And then every transaction, even though it may not be like a
commit.
physical addition of data, is still an add, right? So if you're just modifying the data, it gets treated like this.
Yeah, so
Regardless of what is actually happening to the data stored inside the dictionary, for
yeah,
example,
so
if there's any
if
change.
you're doing operations on a dictionary that is already inserted, then there's no state change inside the state manager, right?
Okay.
Then state manager is only acting as a multiplexer, demultiplexer. So this was a state manager operations for an add and a remove. We do not have update today. It is something that we could add in future so that we can update the configuration of the state provider, for example. But let's say that, so now let's kind of go through your case, which is now that the dictionary exists or a queue exists, it wants to do an operation. It wants to say that, hey, I want to make this change replicated.
Right.
In that case, all the state manager does is kind of adds a little bit of a multiplexing, demultiplexing information. So it knows not only on the primary but on the secondary who the operation belongs to, so
Right,
that it
which
can
one?
just do that.
That way it's the correct dictionary on all replicas
Yeah.
that's getting the updated.
Yeah, it is. In that path, the idea is that it's supposed to be as cheap as possible.
Right. Is that why we haven't implemented an update? Or
No, update would be a state manager operation.
that would be a configuration basically?
So that
of the-
wouldn't affect that part. Just today we have not.
So today, if somebody wants to update the configuration of one of their reliable collections, they would simply-
Configurations are not public yet.
Okay,
So
fair enough. So if you theoretically wanted to do that, would it be a remove and a recreate?
you wouldn't want to do that. So at that
'cause
point
you
of time,
don't wanna lose the data
if
at
we
that,
want to
right?
keep the configuration as part of the state manager, then the state manager would want to have an update. So for example, let's say that your queue wants to have a max
Yeah.
of how many things that you want to keep in memory versus on disk. In which case, and then at any given point of time, you decide that you move to bigger machines, you want to increase your memory usage, you have more memory to give to
Right.
each queue, you might want to be able to say, hey, update my max from 16 to 32.
Nice.
It's interesting.
Yeah.
Sounds sort of cool set.
So basically, what's the code you're writing on a day-to-day basis is native code? I mean, so what?
It
Like,
is.
let's talk about that. So the ultimate implementation of all of this is.
Yeah, it used to be C# when we began.
Uh-huh.
Then it moved into the native for a couple of reasons. One being that we wanted to support Linux, as well as one way of getting there. Not that the core CLI also solves a similar problem,
Sure.
but also potentially like most of the code in Service Fabric is already native, so we can avoid.
But there is also the notion that garbage collection can be problematic in a distributed system like this, a distributed system infrastructure that needs to be.
Yep.
And .NET is wonderful and beautiful, but sometimes it just doesn't make sense for certain areas. So do you use coroutines or do you use the async, old school async that we added, or are you using the coroutines in KTL?
So in State Manager, we use the coroutines.
Rock on.
Yeah.
Okay.
John's a fan.
I have to ask everybody that. So
Yeah.
I think they're awesome.
You
I think
become
our
a big fan.
implementation is killer. All right.
You were saying something about us being the largest user of
We are
coroutines.
the largest at Microsoft. We're the largest user of coroutines in production, without a doubt.
So this sort of one of the things we talked about with Simok also was how this thing changes if you were to break it down from a user perspective, thinking about each node at this. Thinking of it as a per node basis, basically. So you have this sort of stack that exists that's running on all of your machines at the same time. So how does the state manager coordinate across all of the machines to make sure that it is constantly understanding at all times?
So that one, kind of all the cross replica communication is done by the V1 replicator. So for example, in this case, let's go through the add case, right?
Yeah.
When we want to add something, we take the lock. Then what we do is we kind of call to the logging replicator, say, hey, transaction dot add operation, right? I have some change that belongs to this transaction. And the login replicator takes that. If it's time to replicate it, it will basically generate a log record and then replicate that log record out. So on the other side, it will, as part of its becoming logged, it will apply to the state manager, saying that, hey, you had given me this, can you please apply it to yourself? Very similar to how, if you said, that your dictionary update would work, if you had your dictionary that, you're adding an item to the dictionary or updating an item inside the dictionary, you would call, transaction.add. That would go through the state manager, where state manager adds a little bit of a multiplexing information, and then it goes to then it will go to login replicator. Login replicator would add its metadata to it, and then it would come to the V1 replicator,
And then
send
that
it
would
to the other side,
on the machines.
and then on the other side we get the message, we log it, assuming that it's not duplicate, it's not. It's well formed. Then once the logging is done, replicator says, okay, now it's time to dispatch it when it sees the relevant barrier for it. And then it gives it to state manager. State manager removes its data and then gives it to the upper layer. That's why we use the operation data.
Sure. And what are some of the contracts that the state manager has with the T-store, basically, to make sure that every single transaction that's coming in is being demultiplexed and multiplexed in the fastest way possible? And what sort of agreements are we taking across the code that's running in the T-store to enable the most efficient path, basically, for every incoming transaction?
I don't know if that's a state manager kind of part of the contract. Yeah, so from state manager's perspective, we don't really mind what data there is.
Okay.
But there are optimizations that the store can do with the logging replicator.
Right. So that, but then for you, that's just agnostic to everything, because you're just passing it through as one thing. Whatever it is, it's a black box, effectively.
Exactly.
Okay. Sweet. And then what have been, I guess, some of the challenges, like the big challenges you've faced over the years in building this from a more higher level, I guess?
So I would say the state manager wasn't So State Manager was actually built by Preetha.
Okay.
So she built the static version, then the dynamic version. Relatively, out of the three, I would say it's probably the relatively easiest to get a grasp on.
Sure.
So I don't think I had that many challenges
Cool.
in State Manager.
You brought up this interesting point on how you structure your reliable collection. So, do we know if it's better to have one large dictionary with a bunch of different entries in it that might be type object, so that you can have like flexible sets of data in the same dictionary, or is it better to have a lot of small dictionaries that are running around? Because you also did say that this was designed in mind to have less, reliable collections as like state providers that you need to have, with maybe more data types or fields inside them or transactions inside them.
Yeah, so that was how it was designed. So it wants to have, I think the documentation we have is, we said, below 1,000 if I'm not mistaken. But yeah, so basically it's something that about 100 is kind of...
So 100 like reliable dictionaries or 100 queues. And
yeah,
basically.
so you don't want to get above 1,000. 100 is a kind of a good place if you want to go for that many. But generally, we kind of recommend that you have more you have bigger dictionaries as opposed to more dictionaries.
And why is that?
Multiple reasons. Like for example, today we do not page out an entire dictionary. And if we were to page it out, we would not be able to differentiate between what parts of it we would be paging out. Whereas a dictionary can say, hey, following keys are being accessed a lot, but following are not accessed at all. Let me page that part out, but not this, right? Because again, State Manager does not even know the concept of a key or a value or an item, right? All it sees is add operations.
Yeah.
So that's kind of where that kind of logic comes from.
Cool. And then,
Nice.
yeah, that's interesting. And then,
Very much so.
and what are we? I know that there's probably some work being done on this front, but are we looking at ways to sort of improve the efficiency of this stack?
Absolutely.
So that's sort of what you're looking at today, right?
Yeah. So
And I don't know what you can tell us about it, but if you can just give us like a sentence or two on sort of where we're headed, that'd
yeah,
be super
so most of this, kind of State Manager, things that I used to own, like State Manager, Backup Manager, Version Managers, serialization.
good. All these managers. It's like you're a manager.
They have been
Managers.
They have been mostly passed on. So we can talk to Joe about them.
Yeah.
The new things that we are working on is basically trying to see if we can get more perf in kind of, let's say, if we were to rethink certain things, where can we go?
Cool.
Right on. Hey, Mert, thank you for, this. We want this to be relatively random because, this isn't a lecture, so we like to throw random questions at you, and you did really well.
Thanks so much for your time.
Yeah.
I appreciate you coming
And
down.
we are now officially done with the
Reliable collection stack. Yeah.
Great job,
This is the
man.
last step in the video. So for those of you that haven't seen the others, please check out the video we had with Preetha and with Sumak. Along with this one, it'll give you a good sense of how we reliably deliver reliable collections.